Liquids and gases flow because their molecules move more freely than those of solids. It is this ability to flow that makes us refer to liquids and gases as fluids. So in this quest, we study the way fluids respond to forces such as surface tension, capillarity, and viscosity. Have you ever observed that in some ways the surface of a liquid tends to behave like a stretched skin? Now, take for example the formation of a drop of water at the mouth of a tap that's not fully closed. The water looks like it's slowly filling up a balloon. This balloon grows larger until it can no longer support the weight of the water inside it. It is at this point that a spherical drop of water will form and fall off the mouth of this tap. In this lesson, we will be discussing the force behind this phenomenon called surface tension. Now, surface tension is a force acting along the surface of a liquid that is in contact with a gas that makes this surface act like a thin elastic sheet. Surface tension is due to the forces of attraction between the molecules of a liquid. To illustrate how this works, let's consider liquid in a bowl. Now, the molecules C, completely submerged in the liquid, have intermolecular forces pulling them in all directions so that the resultant forces acting on them all add up to zero. But the molecules at the surface B do not have other molecules on all sides, and consequently, the resultant force is acting downward, drawing these molecules into the liquid. This force leaves the surface in a state of tension, hence the name surface tension. This forms a surface film, which makes it more difficult to move an object through the surface than it is to move it when it's completely submerged. Now, here's an experiment you can try at home to better understand surface tension. First of all, you need a bowl of water, a piece of tissue paper, and a dry needle. Now, place the needle on the tissue and carefully place the tissue on the surface of this water. After a minute or two, the tissue sinks to the bottom because it has absorbed water, but the needle stays on the surface. Now we know that the needle should not float and does not float generally because of the density of metal, which is more than the density of water. But rather, its weight is supported by surface tension on the water that makes this surface act like a stretched skin. Quantitatively, the surface tension is defined as the force that acts tangentially on the surface of a liquid acting perpendicular per unit length across any line on the surface. So we can see that the weight W of that needle is countered by the net effect of the surface tension acting perpendicular to the force applied. Surface tension varies from substance to substance. Liquids with high boiling points, such as mercury, have a high surface tension, while alcohol has low surface tension. So in our needle experiment, the needle will sink immediately if we started adding a low surface tension liquid like alcohol. Higher density liquids have higher surface tension because the intermolecular forces are stronger, and this is why surface tension is affected by temperature. At high temperatures, the same liquid will have more volume and less density, leading to a lower surface tension. And based on this, we can say the higher the temperature, the lower the surface tension. Now that we have learned about this principle of surface tension, in the next lesson, we will discuss some of its applications. But until then, see you soon.